Good morning, everyone, and welcome to our ongoing series in Central Region of Science Sharing webinars. And today we have a repeat performance by Lance Rothfuss, who's the Deputy Chief of the Warning R&D Division and currently Acting Deputy Director of NSSL. And he'll be talking about what he calls FACETS, a new watch warning paradigm and framework for progress. So without further ado, Lance, it's all yours.
All right. Thank you, John, and welcome to all who are joining today. And if for those of you who have sat through my presentation in the past, I appreciate you coming back and get a second dose here. So I start my presentation with this little nugget, and courtesy of Al Gerard, MIC in Jackson, Mississippi. I always joke I owe him a beer every time I use this, and now I'm up to about a keg for as many times I've given this presentation. I ask you to take a look at this and give some thought to this, take a look at it, and see if there's anything that you see wrong with this tornado warning. And I don't need you to pipe up or anything like that. Just sort of look at it for a moment. I'll give you the answer here shortly. Take a look at that and see if there's anything that you see wrong with the tornado warning. All right, so you're going to want to throw things at me here for the answer, but unless you're OCD, really there's nothing wrong with this warning except for one thing, and that is if you're OCD, you would recognize that Sunday did not occur on February 21st in 2012. The answer for this question is the year. It was not issued, this warning was not issued in 2012. This warning was actually issued in 1971. And I have taken some liberties in the format and such, but the point of my showing this to you is to make this dramatic that we really have not changed our warning concepts and methodologies in over 40 years. And in writing some paper on this, I actually discerned that it's probably more like 50 to almost 60 years now that we have not changed it. The warning, all caps, text type of warnings. And yes, we've done a few things to adjust the methodology that we issue the warnings. We've done some bullet formats, so that, as I said, I took some liberties with the old warning and put it in bullet format. And we've also gone into storm-based warnings, issuance, but the output from that storm-based methodology is still very similar. It's our deterministic text-based warnings. And I think we all know this bullet right here. Society has changed dramatically in those 40 years. The technology, science, diversity, lifestyle, everything has changed in those 40 years. Yet we continue to pump out text-based deterministic warning products and expect a different outcome. So what we started looking at here at NSSL is this, what are the challenges? What are the things that we're dealing with in our current warning methodologies? A lot of this grew out of the Weather Ready Nation activities and sort of spurred on by that. I'll get to that in a minute. But one of the smoking gun issue for me was this image that Greg Carbon put together, Storm Prediction Center here in Norman. In this image, you see that the pink area, if you add up all the area included in tornado warnings in 2011, that's what you see in the pink area, so sort of graphically represented there. The total National Weather Service tornado warned area is in pink for 2011, whereas the impacted area, impacted by tornadoes, is in that red dot. For me, this screams perceived false alarm. When you start talking about the area that is actually impacted versus the area that was warned on, and you see it graphically there, we have a high false alarm rate or perceived false alarm rate just in our aerial coverage. And so that sort of lends to the first bullet I've got on the screen there, that warning polygons in their current formulations are rather blunt instruments for communicating this dynamic, small-scale, and multi-phenomenon threat. I mean, granted, when we put out a tornado warning, we're not just talking tornado, we're also talking hail, damaging winds, and such. So It's a blunt instrument. It's about the best way I can say that. And then we end up doing things like this with our polygons that the end users on the receiving side really have trouble with. And I show this just as an example, not to pick on Brownsville, but I think every office has found themselves in this sort of situation. You look at this and you wonder how the poor folks in Sebastian, Texas, are responding to that onslaught of polygons. Where are they? Are they in? Are they out? Or what is their situation? So at some point they just kind of get overloaded by it all. So those are some of the challenges. Another challenge that we have is sort of what we refer to as our time-space continuum here. In the event that occurs, we have things that lead up to it, and we start doing products. And from the Weather Service point of view, we start with our outlooks, and out days in advance, and as we get closer to the event, we get a little bit more refined in time and space with our information. And so we start getting into the watches as the event starts to unfold or begin before it unfolds. And as the event does unfold, then we start pulling the trigger on our warnings. And so those are the products that we issue. But I would maintain that this is a very product-centric approach. And as I mentioned, it's deterministic, basically binary. You're either in a warning or you're not, or you're either in a watch or you're not. There is no gradation in there, so it's either all in or not. And I'm taking a risk here by using the word presumptuous, and I don't mean this in a derogatory way, but if you really think about it, it is a presumptuous approach for a meteorologist to sit there in a WFO someplace. And for those of you who know me, I'm not just from the research side. I've sat there at the warning desk many, many nights doing the same thing, deciding what's best for the end user without really knowing what the end user's needs are. So when I decide to pull the trigger on the warning, it's because it's a rather presumptuous act that I know what's best for you as the end user, even though the end user may have lower risk tolerance and these kind of things. So this whole the act of issuing a deterministic warning is a rather presumptuous act, and I think there are better ways to go about this. There are also, when you go into this product-centric deterministic approach, there are these information voids. There's these gaps between the products where there's information that the end user would like to have and needs to have, while there's also information that the forecaster might have and would like to communicate. We tend to rely on other technologies to fill those voids, graphicasts and short-term forecasts and chat, NWS chat, my brain is going, NWS chat. We use other products to fill those voids, but it's not really a part of a continuous flow of information in the same way, in the same manner that the products are issued. So these are sort of inherent challenges we have in the current warning system. There are many more challenges. I just don't have time to go through them, but these are some of the bigger ones that we're trying to look at and address as maybe as a future warning concept, watch and warning concept. So we landed on this sort of seminal question, and it's all, again, born out of some of the Weather Ready Nation activities. I sat in some of those meetings, and I'll be honest with you, I was a little frustrated because we were all asking the same thing, but not really looking at it in a holistic sense. So the question arose, should we continue to address these challenges, all these challenges we have in the watch warning system, in an ad hoc, piecemeal manner? I call that tinkering. So should we continue tinkering with the existing system to address those challenges, or is it time to take a new look, a renewed and rejuvenated look at the entire watch warning paradigm and do it in such a way that it addresses those challenges but in a comprehensive fashion? And that's what I refer to as the reinvention. I think the answer is probably a little bit of both. We can tinker all we want, but I would sure hope that that tinkering that gets done is toward a more futuristic vision of what that new watch warning paradigm should be. And this is really where FACETS gets its start and sorts of things that we're looking at. So if we're talking about a paradigm shift, this goes back to Management 101. When you start talking about shifting your paradigm, you've got to look at certain things. Three things really go into any new paradigm. First of all, it's the good things we do now. You don't want to throw out the good things we do now. So I say first, do no harm. The second thing you need to look at are the challenges. And I've already shown you a couple examples of that. And so we need to look at do we refine, or how do we refine, revise, or reinvent ourselves in order to address those challenges. And the third part of this is the trajectories. Where are we headed? And in particular for the watch warning paradigm, we need to take a look at where science is going, where the tools and society are all going, and pay attention to those trajectories. And so what I'm going to do here for a little bit more, since we're talking about a paradigm shift, let's take an approach here with FACETS that does all three of these things. First, do no harm. Don't throw away the good stuff we do, but start looking at fixing the challenges, and also make sure that we're headed in the same direction as the trajectories of science, tools, and society.
The National Severe Storms Lab is working on increasing the lead time for severe weather warnings. The national average for tornado warnings is currently 13 minutes, but more notice would be helpful, especially for those in charge of moving large groups to shelter. Warn on Forecast will help forecasters issue hazardous weather warnings earlier. The project will give them more info about the chances of strong winds, large hail, and even tornadoes.
Currently, warnings are created by forecasters looking at the atmosphere outside, understanding its volatility, and then comparing that to how they see the Doppler radar presenting what's going on inside thunderstorms. Warn on Forecast is an idea where we're going to take the massive amounts of satellite, radar, and surface data and stick them all into a very high-resolution prediction model. And then by producing new forecasts every 15 or 20 minutes, the forecasters hopefully will be able to use that model to produce warnings that extend out to an hour.
Before the National Weather Service can use this tool, it must be developed and tested. One big challenge will be deciding how to get the model predictions to the forecasters.
I'm going to keep this one very low. I'm just adjusting the track.
These hazardous weather prediction models are going to produce a huge amount of output. And this fire hose of data is just too much for forecasters to handle in real time quickly. So in order to help deal with that, NSSL has developed a related project called FACETS. And FACETS is the methodology which will enable forecasters to focus very quickly on the most important threats.
Once Warn on Forecast and FACETS are proven to be reliable and effective, then forecasters will be better able to inform you of threats nearby. Learn more here and follow us.
Well, most of agriculture, is directly driven by weather. For farmers, our interest is really being able to reduce the economic impact of weather, good or bad. So ultimately, it's about crops being produced more efficiently, being able to distribute those crops to market more efficiently, and having greater quality and greater amount also for that distribution. Also, to avoid runoff of fertilizer or pesticides, that more efficient use of such supplies, also helps the farmer's bottom line. We believe precision farming driven by better weather forecasts can have a strong improvement on farm efficiency and therefore have a positive economic impact. But it's not just better weather forecasts, it's really trying to connect that to the farm processes. So for example, with irrigation, the system is all set up to put the water down in areas that are known to need it tomorrow and won't be wasted because of rain. Deep Thunder refers to sort of our system and service around the business of weather. And so by the business of weather, it means understanding the impacts of weather on business processes. And it's a capability that we've been working on here at IBM Research. And it's different than what you think about like weather forecasts on television. Getting the better weather forecast is ultimately insufficient, even though it's a prerequisite. We really have to connect that to the business. What we do is that we're starting with better weather forecasts and then coupling that to the analytics and visualization that connect to the business processes. So the weather is where we begin, the traditional services weather is where they end. But an important aspect of what some of those services do is that they do collect meteorological data, and we build on that data. So an example of that is work we've been doing in Rio de Janeiro, where we are doing weather forecasts, then using the rainfall estimates to predict flash floods. In other cases, the modeling that we may introduce will be based on different techniques, like statistical techniques. So our ability to predict electric outages for a utility and the restoration effort, we use statistical modeling techniques that incorporate weather and outage and other data from the utility company in order to create the appropriate model for a forecast. This has been very gratifying to see that these ideas are being deployed, people are using it, it's having impact, has the potential to save lives and property. It doesn't get much better than that.